The concept of biomimicry is quite fascinating. Biomimicry is the practice of looking to nature to find solutions to design challenges. One example that comes to mind is a photograph of a peregrine falcon and a B-2 bomber. The side profile of the two is almost identical, although the engineers behind the B-2 bomber did not actually draw inspiration from the falcon. They ended up looking the same because they served the same purpose. So why am I talking about biomimicry? I'm talking about it because of the implications it may have with AI and consciousness. I'm not focused on ethics here. I'm focused on whether it could even work architecturally. In my freshman year of college, I wrote a paper and made a slideshow on the topic of can AI achieve consciousness? There are two models for this: the integrated information theory, which IIT stands for, and the global neuronal workspace, which GNW stands for. IIT suggests that in order for consciousness to arise, there must be a certain level of integration. GNW suggests that in order for consciousness to arise, there must be a global broadcast of information from multiple specialized regions to one another. The IIT theory is more simple in essence. IIT says consciousness doesn't come from intelligence or problem-solving power. It comes from how tightly integrated a system's information is, meaning how much the parts depend on each other in a way that can't be broken into independent pieces. The GNW theory is more interesting in my opinion. For example, let's say your hypothalamus, which is responsible for regulating hunger, processes that you are hungry. Then that information is broadcasted globally to the rest of your brain, centers like memory, language, and decision making. Then you form the conscious thought, I need to get something to eat. And this does make sense intuitively. Thinking conscious thoughts requires memory, speech, and decision making. There is absolutely not one region in the brain that is conscious. It is the whole that is. Both of these theories require specialized regions of the brain. It is just that one prefers integration between parts and the other prefers communication between parts. They differ in mechanism, but overlap in implications for AI. The integration refers to the actual physical, structural, and dynamic integration of our biological brains. There are billions of neurons, constant feedback loops, massive connections between different regions, and reoccurring self-referential activity. If we take these theories seriously and try to translate them into an artificial system, an important question appears. What parts of the brain actually matter? A good chunk of our brains are dedicated to our bodily functions. Parts like the brainstem, cerebellum, and hypothalamus are less relevant to consciousness as we currently understand it. But higher functioning parts like the prefrontal cortex, all the lobes like the occipital lobe and the parietal lobe, and association areas play a very relevant role in consciousness. This is where biomimicry becomes relevant again. Not in copying a brain exactly, but in letting function shape form. Perhaps you have multiple AI agents serving these roles. You lay the foundation for communication between agents. You integrate them well into one another. Is it possible for consciousness to arise then? Maybe. Or perhaps the current AI models we have are not suitable for the job. Our brains are messy, adaptive, self-rewiring neural connections refined by evolution. Is a large language model truly capable of replicating that? I doubt it. There's going to be a need for a new and novel form of intelligence. Yes, the AI we have today is intelligent. It is a different type of intelligence, not necessarily lesser, just architecturally limited. These models are transformers. They take your input and predict the best output. I grossly oversimplified it, but in essence, that's what it is. Can a transformer truly replicate a prefrontal cortex? Going back to our idea of biomimicry, although the engineers of the B-2 bomber did not draw inspiration directly from the peregrine falcon, their design ended up looking just like it. This is possible with silicon. They don't need hardwired carbon brains like ours. The beauty of ones and zeros is that you can make anything out of them. Much like the unintentional similarity between the Falcon and the B-2 bomber, a truly conscious artificial system would likely end up resembling the human brain in its architecture. Our current neural networks are a starting point, but reaching consciousness would require a model that more closely mimics the structure, connectivity, and self-referential nature of biological neurons.